Our lesson for today will be looking at Physics 1505. The focus for today will be Newtonian second law. Basically, we'll be generating equations for different types of scenarios. This is lesson 102. Let us start. Now that we've went through the lesson video whereby we were drawing free body diagrams, and then the free body diagrams will assist us on how to identify the forces which are doing work to the object and the forces which are experienced by the object. So we should understand that we have two different types of forces. Forces which are doing work to the object and the forces which are experienced by the object. Suppose we have this object. Without wasting time, let us look at this particular example. This object is experiencing force applied, or this person is applying force to this object. Then the object is moving this direction, and then there is kinetic friction experienced by the the object. And then let us start by drawing a free body diagram that indicates all the forces which are experienced by the object. This is what we have. We have normal force, we have Fg, we have force applied, and then we have kinetic friction. So these are the forces which are experienced by the object. Now let us try to draw a free body diagram of all the forces which are doing work to the object. Now there is a lesson video whereby we describe what is work, or all the forces which are doing work to the object. Now just to briefly go through what is work. Suppose there's an object, and then this object is experiencing a force this direction, and then the object is moving this direction. The red line represents the displacement of the object. The displacement of the object is moving from left to right, and then this force, this object is experiencing a force which is this yellow line to the right. And then if the surface is rough, it means that we have kinetic friction in this direction, and then we know that we have Fg and normal force. So all the forces which are doing work in this case, we have only two forces, which the first one is force applied and kinetic friction. The reason why we say they do work to the object, in order for the force to do work to the object, the force must be parallel to the displacement of the object. Now when you talk about parallel, we are talking about lines that are like this. When you talk about perpendicular, we are talking about lines which are like this. So all the forces which are parallel to the displacement, just know that those forces are doing work to the object. Now we can see that this is our displacement, and then this is our force applied. So it means force applied does work to the object because it's parallel to the displacement. Then also look at kinetic friction. It's also parallel to the displacement, so it does work. Now looking at the other forces, we can see that they form 90 degrees with the displacement, so they don't do any work to the object. So going back to our scenario, we can see that when you draw a free body diagram of forces doing work, this will be our displacement here. Our displacement is to the right. So you can see that we only have two forces which are doing work. So the free body diagram of the forces which are doing work, it will be like this. Now if we can identify forces which are doing work, then we can be able to generate an equation for this particular scenario. So we start with F net, it's equals to MA. whereby our F net is the sum of all the forces which are doing work. Now, instead of saying the sum of all the forces which are acting on the object, let us only consider the ones which are doing work, because basically this will cancel this one, and then we are left with the forces which are doing work. So writing an equation so that we can solve, we are going to consider left as negative, right as positive. So we can see that our force applied is on the positive direction, plus negative Fk. It's equals to Ma. And then solving this, we are going to have something like this. So if it happens the question asks you about the acceleration of the block, the kinetic friction, force applied, the mass, we are going to use this equation. Now that we can see how we generate equations, I want us to look at this method which will ensure that we are writing or we are calculating correctly. Now remember, I said we take left as negative, right as positive. That is what I initially said, so that you can understand. But let us rephrase this condition. Let's say we take the motion of the object as positive always. Let us not be general and say left negative, right positive. So let us look at this scenario quickly. The person is pushing this object this direction. The object is moving this direction. So in this case, we are going to take left as positive, right as negative. When we say left as positive, right as negative, we are referring to forces. So all the forces which are pointing to the right will be negative, which are pointing to the left will be positive. So we are going to have our force applied, which will be positive, and then we are going to have our kinetic friction, which will be negative. And then we have Fg and normal force. Now let us quickly look at the free body diagrams of these two objects. These two objects are experiencing, actually object A is experiencing force applied to the left, and the system is moving to the left. Then object B is experiencing tension, which causes it to also move to the left. So in this case, let us quickly draw free body diagram of each. So the free body diagram of A will be like this, which is force applied, normal force, Fg, we have kinetic friction, and our tension. Then free body diagram of B will be tension, normal force, Fg, and kinetic friction. Let us go ahead and draw free body diagram of forces doing work on the first object, which is object A. Now we said the displacement of the object is moving this direction. So you can see that the forces which are parallel to the displacement is force applied, kinetic friction, and tension. So we are going to have this force applied, tension, and kinetic friction. So we can see that when we generate an equation for object A, we are going to have these forces. Now looking at free body diagram of the forces doing work onto object B, we are going to have 1, 2, since they are parallel to the displacement. So we have tension and kinetic friction. So from here, it's very simple for us to generate equations for these two objects. For the first one, remember that we take the direction of the system as positive. So we're going to take left as positive, right as negative. Now looking at our free body diagram, you can see that force applied will be positive. Minus kinetic friction minus tension is equals to MA. The second one, for B, by the way, let us not forget including this. These are vectors. Now for B, we are going to have only two forces. Tension will be positive because it's pointing to the positive direction. Minus kinetic friction is on the opposite direction, equals to MA. And you should know that when you're dealing with tension, there is no way that tension can be positive positive or negative negative for both of these objects. There is lesson 103 of this topic. Just make sure you watch it. That's why we continue looking at different types of scenarios, whereby we look at inclined surface, how to generate equations. That's it for this lesson video. This is Mahula SJ. Thank you very much.